Welcome to the lecture on the introduction to mobile robotics. Today we are going to start with the module 3. In this module we are going to discuss an important component used in mobile robotics called an actuator. Actuators are responsible for creating motion in robotic systems and are essential for converting energy into useful mechanical work. What is an actuator? An actuator is a device that creates motion, usually either linear or rotary. To operate an actuator requires an input energy source which may be electrical, hydraulic or pneumatic. The output motion can be seen as a shaft rotating or a rod extending or retracting. In simple terms, an actuator receives a signal and then acts upon it by producing motion. Actuators are not standalone devices, they are always part of a larger system or machine where they perform useful work by creating movement. How an actuator works. For an actuator to function, it needs two main inputs. First, an energy source, usually electrical energy. Second, a control signal that tells the actuator what actions to perform. Based on this signal, the actuator produces an output motion which can be either rotary or linear. Interestingly, in many systems, one actuator may control another. For example, in hydraulic system, a solenoid actuator is used to control the flow of high pressure fluid into the main actuator. This shows how actuators are widely used across various applications. An actuator can also be defined as a motor that converts energy into torque to move or control a mechanism. Apart from introducing motion, actuators can also prevent motion, such as holding a position. Actuator can operate using electrical energy or pressure energy, like hydraulic or pneumatic pressure. The control system may be mechanical, electronic, software based, or even manually operated. Now we will see the function of a motor. An electrical motor is a machine that converts electrical energy into mechanical energy. Motors are widely used to generate torque for lifting loads, moving objects, and performing mechanical work. In this course, we will study different types of motors such as AC motors, DC motors, and special motors like servo motors and stepper motors, which are widely used in robotics. Next, we will see a DC motor. What is the basic principle of a DC motor? A DC motor is an electromechanical device that converts DC electrical energy into rotary mechanical energy. It works on the principle that when a current carrying conductor is placed inside a magnetic field, it experiences a force. This principle is explained by Fleming's left hand rule, where the direction of force, current, and magnetic field are mutually perpendicular. The figure here shows the arrangement of the magnets inside a DC motor and how the rotation taking place. The DC motors operate only on direct current and hence uses only two wires. They were among the first motor to be invented. One major advantage of DC motor is that their speed can be easily controlled by varying the supply voltage. They provide simple mechanism for starting, stopping, acceleration and reversal. Although the initial cost is low, DC motors requires regular maintenance, especially as size and power increases. Now we'll see a brushless DC motor. A brushless DC motor or BLDC motor is essentially a DC motor turned inside out. Here, the coils are placed on the stator and the permanent magnets are placed on the rotor. When current flows through the stator coils, a rotating magnetic field is produced which causes the rotor to rotate. Now we will see the construction of a BLDC motor. The stator of a BLDC motor is made up of stacked steel laminations with windings placed in slots. The rotor consists of permanent magnets, typically having 2 to 8 pole pairs with alternating north and south poles. Magnets Used in the rotor can be ferrite magnets or rare earth alloy magnets, depending on performance requirements. Now we will see how the BLDC motor commutates. Unlike brush DC motor, BLDC motor uses electronic commutation instead of mechanical brushes. To perform proper commutation, the rotor position must be known. This position is detected using sensors such as Hall sensors or optical encoders which provide feedback to the control circuit. Hall sensors. The Hall sensors operate based on the Hall effect. When a magnetic field is applied to a current carrying conductor, a voltage is generated perpendicular to both the current and the magnetic field. This phenomena was discovered by Edwin Hall in 1879 and is widely used for rotor position sensing in BLDC motors. Now we will see the working of a BLDC motor. The, the BLDC motor works based on the interaction between the permanent magnet of the rotor and the electromagnets of the stator. When coil A is energized, the opposite poles of the rotor and stator attract each other, causing the rotor to move towards the energized coil. As the rotor approaches coil A, coil B is energized, and then as the rotor moves closer to coil B, coil C is energized. Next, coil A is energized again with the opposite polarity. This sequence continues repeatedly, resulting in continuous rotation of the rotor. Now we will see the advantages of the BLDC motor. BLDC motor offers several advantages. They provide high precision and efficiency due to the electronic control. There is no sparking, leading to reduced electrical noise. They can operate at high speed and have a longer life since brushes are absent. They also produce low frequency, radio frequency, and electromagnetic interference, making them ideal for robotic applications. Tomorrow we'll continue with the lecture on servo motors. Thank you.